Hello all, I'm Gayatri from batch A3. The project title is SmartFiton using machine learning and deep learning techniques. My team members are Shailaja, Aparna and Tejaswini. We did this project under guidance of Dr. N. Kalyani ma'am. Problem statement. Recognizing human activities and monitoring population behavior are fundamental needs of society. Population security, living assistance, behavior tracking, etc., are some of the main applications that require recognition of human activities. But if one's health deteriorate due to unhealthy lifestyle, tests and diagnosis are time consuming, and keeping track of all human activities is not possible and is error prone. So, coming to the existing system, the previous manual system for monitoring human activities was time consuming, costly, with a risk of errors and negligence. To address this challenge, there is a need for more effective and reliable system that can accurately recognize human activities in real time without limitations or on any manual processes. Some sensor systems have been used but often require to user to wear sensors which limits their effectiveness in open environments. It is crucial to develop new and innovative solutions that can accurately recognize and monitor human activities in real time. Enhanced system can promote a safer and a more secure future for all. So, this task can be automated with the power of machine learning and deep learning pretty much. This project is about an automatic human activity recognizer to detect activities. These are classified as regular physical movements and from our class of activity which is to be recognized using smartphone to make students and people healthy. Coming to the objective of the project is to recognize the type of physical activity the user is performing accurately using the sensors of the phone. The activities which we recognize are walking, jogging, sitting, standing, walking upstairs, and walking downstairs. So we have used machine learning, deep learning, and Android Studio to build our project. So this is the flow of the project. We have collected the human activity recognition dataset from Kaggle. We have pre-processed the data and built a machine learning and deep learning model. Coming to the methodology is first to collect the data, then pre-process the data, apply feature selection and classification, training machine classification techniques like and machine learning and deep learning models, compare the accuracy and prediction and predict the output. This is the literature survey which we have done. So as we can see that there are many limitations of this paper. There is a higher dependency of sensor choice. LSTM model takes long time to train and there are errors in recognizing activities. Hence, we have overcome all the limitations and built the project. So flow of SmartFiton. The sensors collect the data and feature selection is applied, classification models are applied, and the activity is recognized. So coming to the data set, we have collected it from human activity recognition with smartphone from Kaggle. So it contains a 564 feature vector with time and frequency domain variables and also the triaxial acceleration from the accelerometer and the estimated body acceleration, triaxial angular velocity from the gyroscope. So coming to the architecture, the raw data set is divided into 70% training set and 30% test set. So 70% training set is sent into the base model, feature extraction is done, and the model is trained. So later it is test if it is accurate enough. If yes, then it goes to the next classifier. If no, then the feature extraction and the model training methods are further continued. So when all the classifiers are done, then we would be comparing the results. If no, it would again go to the base model feature extraction model training and then checking if it is accurate enough and the process goes on. So steps performed are importing CSV files, checking the shape, column names using data frames, using memory usage of both the data frames using shape function, column function into and info function. Check duplicates and null value using duplicated and mean function. Check null values using is null function and visualize data using matplotlib, cbond, testney, and use label encoder to convert categorical columns to numerical columns. And finally, use machine learning and deep learning models and check the accuracy. Coming to the pre-processing of data, we have checked the duplicates and missing values, applied feature selection, and also classification techniques. So the first method which we have implemented is a k nearest neighbor. KNN algorithm is also used to classify human activities, namely sitting, going downstairs, sitting, going upstairs, standing, and walking, with an objective of increasing the classification accuracy of the algorithm via fine tuning for the parameters of algorithms. The accuracy obtained is 90.804, and the hyperparameters used are PCA and components is equal to 170 and random state is 0, where n neighbors is equal to 17. So we have imported the packages and data, built the model using 564 variables, selected the number of variables, applied PCA for dimensionality reduction, selecting the number of components using PCA, selecting the number of neighbors after PCA reduction, and found the results. So when we talk about the next method is the SVM. So the purpose of using multi-class SVM classifier is that our dataset includes multiple activity done by different actors. So we have used it to obtain long-term activity recognition. And the hyperparameter used here are kernel linear c is equal to 1.0, PCF n components is equal to 190, random state is 0. Accuracy obtained is 96.335%. So here we have imported packages and data, built the model using 564 variables, selected the kernel among RBF, poly, linear, and sigmoid, selected the value of regularization parameter C, applied PCA for dimensionality reduction, selected the number of components using PCA, and found the results. Coming to the XGBoost, the hyperparameters which we have used are learning rate is equal to 1 PCA and components is equal to 180, random state is 0, and the accuracy obtained is 93.450%. So we have imported the packages and data, built the model using 564 variables, selected the number of learning rate, applied PCA for dimensionality reduction, selecting the number of components using PCA, selecting the number of neighbors after PCA reduction, and found the results. Coming to the logistic regression, the accuracy which we have obtained is 93.349%. So coming to the deep learning model, that is the convolutional neural network. So we have used this because the main advantage of CNN compared to other neural network is that it automatically detects the important features without any human supervision. The accuracy which we obtained is 96.335%. So this is the table of the accuracies which we have obtained. So after we have obtained the um, accuracies, we have implemented the CNN model and integrated it with our Android application. So this is the first one is the home page. So here this is the welcome page, and one will be able to keep track of all the daily activities like walking, jogging, sitting, standing, walking upstairs, and walking downstairs. So it is advised to place the pocket in your front pocket to not adversely affect the recognition accuracy. So once done, we will be pressing the start button to monitor the fitness. Pressing the start button means that the application will begin gathering data from accelerometer even in the background. So simultaneously, you can watch the real time rating of the activity which is being done by the user. And once done, you can one presses the stop button, and there is another option of table below, which in which you can view the activities and their corresponding confidence in real time. Similarly, press on the statistic button to view their fitness and statistic over different period of time. So here the person is sitting, standing, walking upstairs, running, and walking downstairs. So coming to the readings, a user can tracked the readings for past hour, past day, past week, and past month. So these are the readings of each individuals of our team members. So everyone's activity is different for past month. Similarly, it can be tracked for day, week, or month. So coming to the conclusion, the best classification rate in our experiment were 96.33 and 96.33, which was achieved by SVM and CNN respectively. And also among the machine learning classifiers, KNN and SVM improved the most after applying feature extraction and dimensionality reduction using PCA. So, conclusively, CNN and SVM are optimal choice for our problem as we have got the highest accuracy. Thank you.